Today we're going to look at how to describe and summarize a single variable in SPSS. This is known as descriptive statistics or univariate statistics, and we'll be using one key menu command called frequencies. Let's look first at a variable in the NES dataset. This variable is partisanship. It has a 7-category variable that measures people's attachment to the Republican or Democratic Party and how intensely that attachment is held. To do a frequency analysis, we go to the Analyze menu, drop down to Descriptive Statistics, and then go across to Frequencies. Click on that. This brings up the Frequencies menu box. Again, we can sort these variables in a way that will help us find our variables that we want. So we're going to display variable names rather than variable labels, and I'm going to sort these alphabetically, and that will help me find the variable that I want, which I know is PARTID. There it is. So we can take that, we can double click it if we want to put it into the variable box, or we can use the arrow. Either way, it moves it into the list, and you can do more than one variable at once. It will run all of the frequency commands on all of the variables you put into the box here. So if we wanted to add this one, we could add that, we could add another one. But for now, let's just look at party identification. Okay, now if you do nothing else but add the variable and you press OK, here's what you'll get as your output. What this produces is, first of all, a little summary of the cases. So you have 1,785 valid cases, 22 were missing data for some reason. And then we have below the frequency distribution. That's the default settings. This produces the different categories for the rows, strong Democrat, weak Democratic, etc., all the way through other or minor party. Then you have the total number of valid cases you can see is 1,785. And then they show you what the missing data are. There's 22 cases, 17 of them were people who said they were apolitical, and the survey bounces them out of this question, or it didn't apply to them for some reason. You have the percent of the total 1807, and then you have the valid percent. So 346 divided by 1785 gives you this 19.4%, whereas 346 divided by 1807 gives you the 19.1%. So generally what you're interested in looking at is the valid percent. You can see it sums up to 100 among the valid cases. It sets these missing cases aside. But if for some reason you were interested in looking at the percentages of the overall sample that fall in, including the missing, then you'd want to use this column here, the regular percent. You can see on the end too the cumulative percent that adds up each row as you go along, and of course accumulates up to 100%. Okay, now that frequencies dialog box, again, if you do nothing, it will give you this output. But we can do a few more things with that dialog box, and it gives us some more descriptive statistics. So let's go back in. Okay. First thing we can do is go over here and click on the Statistics tab. This gives us a bunch of different options that we can include with our frequencies output. We can get quartiles, divides up the set of cases into 4 quartiles and shows you the number that occurs at each of those cut points between the quartiles. You can create your own cut points if you wanted to put it into 10 separate groups or 2 separate groups or 5 and do quintiles, for instance. You could do it that way. And you can also do a percentile, so you can show what percent is at the 90th percentile or the 100 or the 99th percentile, or however you want to do that. There is also a box here for central tendency. You can get the mean, the median, the mode, or the sum, which just adds up all of the data. Not often very useful, but sometimes is in some circumstances. And then there's also a box down here for dispersion. We'll look in a little bit later at how you can calculate a standard deviation and a variance. You can also get a range, minimum, maximum. And then also you can get some distribution statistics. There's a skewness statistic that we'll look at, and there's a kurtosis statistic that we're not going to use. For now, we're going to look at the central tendency. Now we have party ID, which is nominal or perhaps ordinal variable. If you want to make the case, it runs from being more Democratic to being less Democratic as you move to being more Republican. Either way, it's certainly not interval level, so we're not going to be able to click on the mean. So what we really want here are the median and the mode for this variable. We'll say it's ordinal. Now, of course, you can click mean, and it will produce a mean for you, but that mean will not be meaningful because you'll be applying it to data that's not interval level. So you have to know your level of measurement when you're going in here to look at your central tendency and making your selections. And if you output a statistic that is incorrect, that's going to be an incorrect answer on an exam, or it's going to be something that's going to be problematic if you put it in a research paper. So let's leave the median mode, hit continue, hit OK. Go look at our output window. All right, scroll down. So you can see it produces the same thing it did before because we did a frequencies command, but it's added a few things in that little summary box at the top. Not only is it giving you the number of valid missing cases, but it's also told you what your median is, the category 3, which is independent. Okay, so that's the median category. 50% of the cases fall below, 50% fall above. And it showed you what the mode is. The one with the most cases is strong Democrat. And you can see that just looking across the cases and see that 346 is the biggest number here. And in fact, for median mode, you really actually don't need this box. You can do that just by looking at the distribution here, because you can simply see which category has the highest number of cases, and that's 346 is strong Democrat. And to figure out the median, you can look at which cumulative percentage actually crosses into 50%. So you know here that when you're in category 2, 49.8% of the cases fall in category 2 or lower, so you haven't reached the median point yet. And then when you move into category 3, sometime as you move through those 206 cases, you get to the median case. And so 50% fall at 3 or below, and 50% fall 3 or above. So your median category is 3. So really you can use the cumulative percent to figure out your median. But of course it's just as easy to ask SPSS to do it for you. Well, as I said, you can't use a mean for an ordinal level variable like this. So let's take a look at an interval level variable and calculate a mean for it. And let's do that using the countries data set. We're going to use a variable that measures each country's inflation rate. So again, we go to Analyze, Descriptive Statistics, go to Frequencies, and again, I'm going to display the variable names, and I'm going to make them alphabetical because I know the name of the variable I want. Right there. So I'll click that in there. Okay. I'm going to go to Statistics, and now I'm going to ask for my mean. I'll also ask for my median as well. We're going to continue. Okay, now you can see that it's produced this new box for the inflation rate. You can see the mean is just under 13. The median is 3.9. This should tell you the data is skewed. And you'll see also that the frequencies produces a frequency distribution. But there's a problem with this frequency distribution. It's not particularly helpful. You can see how many categories it has. It goes on and on and on and on and on and on and on. So it's really not helping you to see the data very well or understand how it's distributed, because the problem is with interval level data, most cases have a unique value. And so there may be some cases where 5 of these countries have a value of 0.50, but a lot of them have unique values. There's only one country that has 1.6. There's only one country that has 1.62. So you end up with these big, long tables that aren't very useful. Now, one way you can do that is afterwards go, oh gosh, I didn't really want that. I'm going to click on that, and then you can just go over here and press delete on your computer, or go up to the menu and just press delete and get rid of it. Well, that's one way to do it, but there's actually a way to avoid producing that unnecessary output to begin with. If we go back to our menu, we go back to our frequencies distribution, over here there's a box that says display frequency tables. You can uncheck that. The default is to have it checked, but you can uncheck that, which is what you're going to want to do when you have interval level data. Now when you press OK, you go look at the output, it produces just that box, doesn't produce that big long frequency distributions table. Now, there's even more. I'm sure you won't even believe it, but there's even more that this wonderful statistics command does, and that includes charts and graphs. These are descriptive charts, descriptive graphs. If we go back into our NES data and we go to our frequencies, we had already looked into the statistics box. Let's take a look at the charts box. Okay. The default is not to produce any charts. So if you don't mess with that function, that option, nothing will be produced in terms of charts. You have three charts. You can do a bar chart, a pie chart, or a histogram. Now, we'll talk in class about the advantages of the different kinds, but the one thing to keep in mind is that if you have nominal or ordinal level data, you need to choose a bar chart. If you have interval level data, you need to choose a histogram. Now, the NES data is not intervals, it's ordinal, so we're going to choose a bar chart. You can make the height of the bars represent the frequencies, the raw number of cases, or the percentages that fall into each category. Now, it doesn't really matter which one you do. The bar chart will look exactly the same. It just shapes what the y-axis, the vertical axis, will display. Let's choose percentages. Okay, now if you want to get rid of the frequency tables, you may. We've already produced them earlier in our output, so let's go ahead and turn those off, and we can go ahead and produce the chart. You can see it produces the median and mode because those statistics were still checked in. And then here's the bar chart that shows the percentage here on this axis that fall into each of these different categories. It's a very helpful chart. Now you'll notice that the bar chart has space between the bars, and that's the indicator that these are discrete categories. This isn't a continual interval level variable, that these are different categories, and we need to keep that in mind as we look at the data. Now, how would we look at a histogram? Well, let's go over to the countries data set and look at that inflation rate variable again. Okay. Go into charts, and this time we'll ask for a histogram because it's interval level. Hit continue. We don't want a frequency table, so we'll just leave it unchecked. Go look at the output here. All right. And what SPSS does is create bins, essentially, because this is data that has various values, right? There, as we saw in the frequency table, there's a lot of unique values. So it creates categories, and it dumps the cases into categories. So you can see that there's a little over 150 cases that fall in this low inflation rate, and then there are a few that have really, really, really high inflation rates of 200, 300%. And then there are some that have deflation rates, right? Negative inflation rates that are down over here. You can see how the bars are put against one another. That's an indicator you're looking at a histogram because it's created these bins of values that are continuous. They bump up against one another, unlike a bar chart where there's discrete categories that are distinct from one another. Now, if you do this wrong and use a bar chart for interval level data, you're likely to get a really, really odd outcome. Let's go ahead and look at a different variable from this country's data set. Let's look at the gross domestic product. So the number in standardized dollars, how much each country's economy produces in goods and services each year. So we'll go back over here. Let's get rid of that. We'll go back up to GDP. Like that. And let's ask incorrectly for a bar chart. Right? We should be getting a histogram because this is an interval level variable. But what happens if you do it wrong? Well, you're likely to get something really odd looking, and it's going to look like this. Okay, what's going on here? What are we looking at? Well, here's what you're seeing. Every single country has a unique value on this variable. The GDP in millions of dollars is different for every single country. So you can see that there's a frequency of 1 for each particular value. Well, this doesn't tell you anything. All this tells you is that each country has a unique value, and that's not really interesting to know about it. So when you're looking at data like this, a bar chart will really not tell you anything that you will find interesting. On the other hand, if you go back in and you run this as a histogram instead, now it's provided at least a little bit more interesting information for you, which is that most of the countries are really, really low down here in terms of their size of their economy. A few countries are a little bit bigger, and then there's a number of outliers that skew way far to the right on this data. let me show you one more thing that the frequencies distribution, or the frequencies command will do, and that's to help you look at dispersion and skewness of data. We can go to this GDP data and go back to the statistics box. Okay, we asked for the median and mode, but we can also go down and ask for the standard deviation, calculates it for you nicely. You can ask for the variance. You can ask for the range if you wanted. So the difference between the minimum and the maximum. You put the minimum and maximum in there. Don't worry about the standard error of the mean. We can also ask for a skewness statistic, and I'll talk about skewness in class a little bit, but it's a measure of how symmetrical the distribution is. Is it symmetrical on either sides of the central tendency, or does it skew towards one way or the other? Okay, so let's click continue. We will turn off our chart here because we don't really want a chart. We don't want a frequency table. We just want to see those statistics. Okay. All right, so you can see it produces it all in one nice little box for you. 139 valid cases, 69 are missing data on this measure. You can see the median value, the mean value, the median value. It shows you the standard deviation. The variance is such that it needs to be put into scientific notation. You'll see the skewness variable here, 8.053, and then you see the standard error of skewness. Now, as I'll talk about in class, the way that we can evaluate whether there's skewness or not is whether this value, the skewness, is more than 2 times the size of the standard error of skewness. If that's 2 times the size of that, we have a high level of skewness, or at least one that's worth noting, and it's not simply an artifact of random error in the way the variable is distributed. Here it's quite large compared to the standard error, well over twice the size of it, so we do have a high level of skewness, and that makes sense looking at the distribution where we can see that it's all concentrated down here, and then there's a long tail out here to the right, which makes it positively skewed. You can see the minimum value, the maximum value, and the range is located between these, just the difference between these two. Okay, well, that's how you use the frequencies command. And again, this is all this all consists of options that you have available to you. You can ask for a frequency table or not. You can ask for different kinds of statistics depending on the kind of variable you have. If you had a ordinal variable, for instance, you would not be able to calculate skewness. You wouldn't be able to calculate any of these variables. You could calculate the range and minimum, maximum, but of course that's not really interesting for an ordinal variable. You wouldn't be able to calculate the mean, but you might look then for the median and the mode. So you have to know your level of measurement to choose the proper statistics. Same thing goes for the charts, where you choose a bar chart for an ordinal or nominal variable, use a histogram for an interval level, and as I'll talk about in class, stay away from the pie charts because they're not very effective in conveying visual information.